Hi, in today's video we're going to take a look at AMREL, American Reliance power supply. It's a PPS-2322 programmable DC power supply. This power supply has two channels. They can operate either independently or in tracking mode, which is very useful if you are doing any circuit that requires both positive and negative power supplies. I have already done a teardown of this and showing its pretty detailed internal constructions, and if you are interested you can go take a look at my website. So in today's video actually we are going to take a look at some of the performance characteristics of this power supply. Another thing I mentioned in my blog posting is that this power supply doesn't have a fan controller, which means the fan is on at full blast, as soon as it turns on. So let's take a look at that, and it's actually pretty loud. So now let me turn on the power supply, and you will hear immediately the fan is from the background. Now it might not sound as loud as it actually is, but trust me that in practice you probably don't want this fan to be on all the time. So after the performance verification that we do, I'm gonna modify this unit to add a temperature controller. So hopefully we can reduce the standby noise, and also most of the time, if the operating current is under 2 amps or it's significantly less than 2 amps, the unit doesn't warm up to warrant the fan operation. Right now you can see actually both of the channels are on. This is because when I turned them off before, actually the channels were in this state. So this is just something you need to be careful about. So for example, if I turn it off, next time if I start the unit, the channel 1 would be off and channel 2 would be on. So let's try that out. Now I'm turning it off and turn it back on. So you see the channel 1 now is off. So typically I think a lot of the modern, a lot of the supplies nowadays, if you turn it on, it would always be off. The output would always be off to begin with, so that you don't accidentally put your power supply supplying something that you were not expecting to your circuit under testing. Anyway, that's just something minor I noticed. So now let's take a look at its output accuracy, and for that we actually just need my BK Precision 2709B is probably good enough. So let me put that in here, and let's put it into DC mode. By the way, the output, now I have it connected to the leads directly. So this is the channel that I'll be measuring. So now let's right now it's off. It's output a little bit of voltage. As I mentioned in my blog posting, this is because there's no relay in this unit, so that the output is turned on and off by by turning on and off the pass transistors. And so it's kind of a soft switch. That's why you are seeing that the voltage is not exactly 0. Now let's turn the output on. Okay, I turn output on. So it's a 1.011. So it's it's probably within range, within spec. It only has a 12-bit DAC, so the output accuracy is plus minus 10 millivolts. So now let's put something, let's do VSET. Let's set it to be 5 volts. 5 volts. So you'll see it's a 5.019. And let's just put it all the way to 32 volts and see what we get. So VSET, 32 volts, enter. And it's 3204. So from this standpoint, it looks okay. And let's also take a look at the tracking supply portion. So if I press this and hold it, oops, press and hold this. Now the two channels are in tracking mode. So in this mode, what we have is right now I'm on the main channel. So now let's put this here on this side. We can see this here, and if I measure the second channel, it should also be 32. So the second channel is 32, and the first channel is 32. So let's see, the first channel, 32. So the tracking is pretty pretty accurate as well. Now let's just verify another voltage. So let's say we wanted to track both channels at 15 volts. So now channel 1 is 15 volts, and the channel 1, the display is 14.99. There's some, little bit of discrepancy, but that's to be expected. And let's see, it's 1502. So again, the tracking is fairly accurate. And before I go ahead and do more measurement, I just want to briefly show you the setup we have here. So this is the power supply, as you see before, and here I have this kilowatt energy meter. It gives you a rough idea of the power consumption. Right now we don't have anything hooked on. It's consuming about 42 watts, and you can see that if I change between the VA and watts, you will see that the power factor is about 80%, which is exactly what the manual says. And here you will see that this is the DC load that I built before, so we can use this to measure the current capability. So now let me turn on the DC load. Hang on. Okay, so right now we're seeing just a little bit of current flowing through. And one thing I wanted to mention again is that this power supply, because of the internal wire leading to the front panel, is very long, so there is some significant voltage drop across those wires. That's just something you need to be aware. If you need to make sure that the output is spot on, you need to use the rear side terminal with the voltage sensing compensation. So anyway, so now let's see that right now we have 15 volts. I'm going to crank up the load gradually, and you will see that the output already started dropping. So now we're at, let me crank it up, we're at 1 amp, roughly 1 amp, and we dropped about 20 millivolts at the terminal, which is okay, depends on what you do. In a typical application, it doesn't really matter that much, especially given the type of application this particular power supply is designed for. So now let's keep cranking it up, and as soon as we hit, let's see, right now 1.5 amps, and so the maximum here would be around 2 amps. So as soon as I go over 2 amps, you're gonna enter the protection mode, which means you will see that. Hang on. So the output would drop because of the current now exceeded. So let's have the current back to 1.99, which right now the output you will see it's only 14.95, which is still pretty good. So let's take a look at what is the power consumption right now. Because there's no relay, so which means that the input is directly, excuse me, let's move this wire up. So right now we're consuming about 148, 149 watts. And because of it, there's no relay to switch between the windings. So it doesn't really matter what is the output voltage, it will always consume the full power from the input winding. So let's to verify that, let's set the voltage to something lower. So let's set it to let's say 2 volts. So right now we're still consuming about 2 amps. So the actual power dissipation is it's only about 4 watts, right? But as you will see, if I can move this camera, hang on. If I show you what is the power consumption here, it remains 148 watts. That's because it's a linear power supply. The power dissipation is totally dissipated in that pass transistor. So this is the one-channel operation. Now let's take a look at the characteristics when both channels are on. So now we have set it up to have the 2 channels in series, and as you can see, the first channel goes out, so the positive is connected with the negative on the other channel, and because this is a tracking mode, right now, I'm seeing double the output voltage on my meter here. So if I put a load on this, both channels are going to be dissipating power at the same time. So now let's hook up the load, and at this moment we are dissipating about we're drawing about 100 milliamps current. Now let me start cranking up the load. So now, as you can see, we are 0.2, 0.3, no problem. We now are. I'm just gonna turn it to the maximum current of 2 amps. The output did drop a little bit, but that's to be expected. Especially the wiring I'm using for this connecting this second channel, as you can see here, is not very thick to be able to handle this the type of load. But that said, it doesn't really matter. Let's just see how well it handles the current here. So now I can go all the way up to 2 amps, and as soon as I hit that 2 amps, the current limit, the constant current indicator will turn on. So which means basically it enters current limiting mode. So at the full load, let's see at the front terminal here, and we can see. Let me just see if we can poke this through. It's 1.94, and on the other end, we also got 1.93. So the tracking remains pretty good. And because now these 2 channels are in series, if I drop the voltage right on this output, theoretically, when the voltage approaches 0, that's when the maximum power is dissipated. So what I want to show you next is basically trying to push the power supply as hard as we can. Now we are setting these, let's set the output to, let's say, 0.2 volts, right? And so which means, the output is almost 0. Now the full power are going to be dissipated on those 2 sets of the pass transistors. So let's crank up the current. Now we're at 1.5, 1.7, 1.9. Now I enter the constant current mode. So let's just say it's 1.65 right now. Let's take a look at what is the power consumption of the power supply right now. So let's see, the power meter right now has about 252 watts. So that you could get an idea what the current, the power dissipated in those pass transistors are now. It's about 120 watts per set. Now, if I'm just feeling this, the case is actually not that hot at all. It's just lukewarm right now. also mention that this unit is, opening up is slightly different than other instruments that I've seen. Is right now I removed the rear 3 screws, and I'm gonna so you kind of pry open, well, not pry open, slide carefully to the back, and now you can't slide anymore. So this whole thing, actually, you have to kind of pry the case outwards. If I can do that here, I might need to. Here we go. So now this actually unit comes up. And as you can see, after I take the top off, is that the opening here, which is it's smaller than actually the opening out at the top of the unit. So what happened is this whole thing is it kind of clamps onto the power supply. So you just need to be aware of that when you're taking it off. Anyway. Since this is not a tear down per se, we're gonna just take a quick look at this unit, and as you can see, we have a this is the MCU board, the microcontroller board, and towards the front you can see the C transformer, and it's very nice, and this power supply inside is very clean. Unlike a lot of the cheap power supplies that you've seen, this one actually is fairly decent layout. So the fan is actually connected right to the board that is soldered onto this board here, and what I'm planning to do is to replace. To put a controller inside in between, so that the fan only spins when the temperature raises above a certain threshold. And so I went ahead and built a temperature controller. And I'm not sure why most of some of the power supplies back then didn't have a temperature controller, especially this one. It has the microcontroller board already. So you would think it's pretty simple to add a temperature controller. Anyway, so the circuit here is actually very, very simple. You probably have seen this before, but really, we have a 2-channel configuration. So this basically is just a comparator, and its positive input is has a voltage divider set as half of the supply rail voltage. And on the negative side, we have a thermistor connected to the ground, and this one is nominal 10K. So when the temperature rises, this value can drop. When it drops below 6.7K, which is your threshold, this comparator is going to flip, and then the outside is going to be turned on to drive this MOSFET, and you can drive the fan directly, or sometimes you can use a relay. Depends on your configuration. But because there's no relay in this unit at all, I just use the MOSFET here to turn the fan on. And the other channel is exactly the same. So as you can see that the configuration is identical, and output actually is ward using this 2 3K resistors to turn the fan on. So either channel, when it's getting too hot, it will output a high, and the fan would be turned on. Another thing to notice is we have this 267K connected between the positive input and output. So that's just to add a little bit of hysteresis, so that you have this typically 1 degree or 2 degrees interval so the fan doesn't kind of on and off when you are near the control temperature. Anyway, so the circuit here, that's the circuit, and so here's a little board I built. It's quite simple, and the wire looks a little messy. Actually, it's really not. So when you see here, this is the original input the two wires to the fan. And so the fan output right now, I kind of, this two wires connected to this connector. So basically, we're really not changing the circuit except for, that much. We just insert this controller board into the power supply portion of this to the fan. So now, as you can see, these are just some of the wires. I have this thermistor connected to. I used the existing mounting hole and had one thermistor on this heatsink, and the other one is here on the other side of the heatsink. So now, if we turn on this power supply, we'll notice we can see the performance. By the way, so I'm planning to kind of put this upside down here and have a tape or something, on this this two caps, so there's enough space here for the circuit. Anyway, so let's give it a shot. So right now I can turn on. Oh, the power supply is already on, and we just need to hook up the load. So let me crank up the load current so that it will heat up fast. So now let's do a maximum 2 amps. Let's see when we're gonna hear this fan kicking in. So let's feel this. It's getting a little warm, so I suspect that the fan gonna be engaged pretty soon. So now you can see the fan started when I apply the load. So now let me disconnect the load, and the fan gonna be running for a while, and it will stop, hopefully. So that's where that hysteresis is important, because you don't want to, when the temperature fluctuates about your control point, you don't want the fan to be on and off always. So here, basically, right now I remove the power, so the fan will still be on for a while until the temperature drops below the threshold. So here we go. So now the fan is off. So anyway, I hope you enjoyed the video, and hope you learned something new, and I will catch up with you next time.